Myself, Rajendra Skarale. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about entropy change and spontaneity. Now in last period we will discuss about the first parameter for spontaneity is the enthalpy change and spontaneity, that is decrease of enthalpy or negative value of delta H, that means exothermic reaction is the criteria of spontaneity or regarding as a driving force behind the spontaneous process. But there are some limitations to that criteria, so that criteria gets failed and the second parameter for spontaneity is introduced, that is entropy change and spontaneity. Now we are first will discuss about the information about the entropy and then we will discuss about this criteria. First here write down entropy, which is denoted by capital S. So what is the definition of entropy? Entropy is nothing but the property of a system which measure the degree of disorder or randomness in the system. That means it is represented by capital S. It is a state function. It is an extensive property. Now here write down second term, change in entropy. That is delta S. Actually, entropy is nothing but the property of a system which measures the degree of disorder or randomness in the system. Now, let us consider the picture in the talkies. When the picture in the talkies start the public is sit in the particular rows and columns. That means during this picture there is order equal to 100% and disorder is 0%. Here disorder is 0% means entropy of that talk is also 0. But during the interval or after the end of the picture in the talkies, the public is randomly distributed where order is 0% and disorder is 100%, and here the entropy is maximum. That means here this entropy measures the degree of disorder or randomness in the system. This is the proper example set to the definition of entropy. Now we are write down change in entropy, that is delta S that is difference in the entropies in the final and initial states of the system. It is represented by delta S. That means here delta S equal to S final minus S initial. That means here where S initial and S final S initial and S final are the entropies in the initial and final states of the system respectively. Now we are for chemical reaction, delta S equal to S products minus S reactants. That means here where S reactants and S products are the entropies of reactants and products of the chemical reaction respectively. Now we are changing entropy for chemical reaction is concerned with changing rearrangement of atoms or ions in the reactants to that in the products. Now we are changing entropy during a chemical reaction may be estimated quantitatively by the consideration of the structures of species taking part in the chemical reaction and the structure of the products formed. Now actually change in entropy is the difference in the entropies in the final and initial state. So change in entropy for chemical reaction is concerned with rearrangement of atoms or ion in the reactant to that in the product. That means that change in entropy during a chemical reaction may be estimated quantitatively by considering the structure of the species take part in the chemical reaction and the structure of the products formed. Now here write down change in entropy delta S and heat involved. That is Q reversible. Now here ratio of amount of heat absorbed by the system isothermally and reversibly and the absolute temperature at which amount of heat is absorbed. That means here delta S equal to Q reversible upon T, where that means for a reversible process at equilibrium, delta S equal to Q reversible upon T. That means here where Q reversible is the amount of heat absorbed by the system isothermally and reversibly, and is the absolute temperature at which amount of heat is absorbed. Now here it is expressed in calorie per degree Celsius, expressed as entropy unit EU or joule per Kelvin per mole. Now here delta S equal to Q reversible upon T. That means here delta S is directly proportional to the Q reversible and inversely proportional to the absolute temperature. How this relation takes place? This can be explained as below. That means here, write down explanation. Point number 1, when amount of heat is supplied to the system, what will happen? Hence, the kinetic energy of the molecules increases. Hence, the molecular motions of the molecules increases, and hence the disorder or randomness in the system increases. That means here, hence entropy of the system increases. Meaning is that hence change in entropy delta S is directly proportional to the amount of heat absorbed by the system. That means from this point it is clear that delta S is directly proportional to the Q reversible. Now here I write second point. The distribution of heat also depend upon the temperature at which the amount of heat is supplied to the system. Now here entropy of a system at higher temperature is more than the entropy of a system at lower temperature that means temperature is also a measure of average chaotic motion or randomness of particles in the system. That means here, hence, entropy of the system increases. Hence, change in entropy delta S is directly proportional to the absolute temperature. That is, delta S is also directly proportional to T. Now in first point, delta S is directly proportional to the Q reversible, and in second point, delta S is directly proportional to the T. That means this is regarding about the individual effect of Q reversible and T on the change in entropy. But in the third point, we will discuss about the combined effect of Q reversible and T on the delta S, that is change in entropy. Now here when amount of heat is supplied to the system having small amount of disorder or randomness at lower temperature result in the a large increase in amount of disorder or randomness in the system now here at lower temperature large increase in the disorder or randomness in the system. In a similar manner, when amount of heat is supplied to the system having more amount of disorder or randomness at higher temperature, result in a small increase in the amount of disorder or randomness in the system. That means here, hence change in entropy delta S is directly proportional to the inversely proportional to the absolute temperature at which amount of heat absorbed by the system. That means here delta S is inversely proportional to the T. Now let us observe here at lower temperature there is large increase in the amount of disorder or randomness in the system, and at higher temperature there is small increase in the amount of disorder or randomness in the system, meaning is that here change in entropy delta S is inversely proportional to the absolute temperature. Now here write down entropy as a state function. This topic is only for NEET and JEE. Entropy or change in entropy as a state function, meaning is that it depends upon initial and final state of the system and not on the path. That means here consider a system consisting of a cylinder containing a gas fitted with a massless and frictionless piston which is in contact with a large heat reservoir that is surroundings. Now here, first point, consider isothermal and reversible expansion of the gas from volume V1 to V2 by absorbing amount of heat Q reversible at absolute temperature capital T. Now listen here. Consider the isothermal and reversible expansion of gas from volume V1 to the volume V2 by absorbing amount of heat qv at absolute temperature T. That means here hence change in entropy delta S of the system is delta S system equal to plus, or you may simply write down Q reversible upon T. This is your equation 1. Hence change in entropy delta S surrounding of the surrounding is delta S. Let me say write down the reservoir. That means here delta S surrounding equal to minus Q reversible upon T, equation number 2. That means here where minus sign represent that the same amount of heat is lost by the reservoir which is also called as surrounding to the system. Hence total change in entropy delta S total is, that means here delta S total equal to delta S system plus delta S surrounding, that means here plus Q reversible upon T plus in bracket minus Q reversible upon T That means plus q reversible upon t minus q reversible upon t, and here you will get 0. This is your equation number 3. Now here consider isothermal and reversible compression of the gas from volume V2 to V1 by evolving amount of heat q reversible at absolute temperature T. That means here heat is transferred from system to the surrounding, hence change in entropy delta S system of the system is delta S system equal to minus q reversible upon T. This is your equation 4. Now where minus sign represent that same amount of heat is lost by the system to the reservoir, that means surrounding. That means here, hence change in entropy delta S surrounding, that means of the reservoir which is also surrounding is delta S surrounding equal to plus q reversible upon T. This is your equation 5. That means here hence total change in entropy delta S total is given as that means here delta S total, here you may also write down simply T equal to delta S system plus delta S surrounding, that means minus q reversible upon T plus q reversible upon T, and this become 0. That means this is your equation number 6. That means here adding equation 3 and equation 6, we get delta S1 plus delta S2 equal to 0. Hence, the total entropy change for complete cycle is 0. That means here hence entropy of the system after the end of cycle is same as it has initially. Hence, entropy is a state function. Now the total entropy change for complete cycle is 0. Hence entropy of the system after the end of cycle is same as it has initially. That means here initial and final states are same, but here paths are changed. First path is the expansion and another path is the compression. Meaning is that entropy depends upon initial and final state of the system and not on the pathway in which change is carried out. So entropy is a state function. Now this is regarding about the entropy change and spontaneity. Your first term is entropy S, second term is change in entropy delta S, third term is change in entropy delta S and heat involved Q reversible, and fourth is entropy as a state function, and remaining part of this unit will be discussed in the next lecture.